How Jackhammers Work. Source: How Stuff Works. By visualgk.com. Concrete, asphalt and rock are hard, sometimes really hard, to work with. Thanks to that toughness, roads and building foundations last for decades. But when rebuilding or mining projects require removing these unyielding substances, a sledgehammer just isn't enough. That's when jackhammers come in handy. T-shaped jackhammers are among the most iconic, fearsome, and ear-shattering tools on construction and demolition sites. Because they combine two fundamental human hand tools, a hammer and a chisel, in one mechanized body, they are also one of the most useful. These tools really are necessary for all sorts of major projects. That doesn't mean jackhammers are easy to use. They tend to be unwieldy, with some weighing nearly 45 kilograms, meaning that safe operation requires a user with some muscle. Otherwise, you risk dropping the tool, which could damage the innards of the jackhammer, or the person using it. Jackhammers combine all the force of a falling sledgehammer, and the power of the pneumatic drill, to make easy work of cracking concrete, and turning rock into rubble. Jackhammers were first invented in the 1840s, for use in the mining industry. However, their ability to break apart stubborn material has expanded, out of caves and onto construction sites, around the world. There are three types of jackhammer: pneumatic, electric, and hydraulic. The most commonly used pneumatic hammers rely on compressed air, to move an internal piston, that drives a chisel at the end of the tool, moving it rapidly back and forth. The internal system of the jackhammer is governed by a series of valves, that open and close, to allow compressed air to quickly flow throughout the tool. Inside a jackhammer. How compressed air causes a chisel to crash into concrete, and split it into pieces. Air compressor. Compressed air is supplied to the jackhammer, typically from a diesel engine air compressor. Pressure chamber. The cylindrical body of the jackhammer acts as a chamber to store incoming air. Driving the piston. When the trigger of the jackhammer is pulled, a valve is opened, to allow compressed air to flow above the piston, driving it downwards. Striking the chisel. Also known as the bit, the chisel is struck rapidly by the piston, forcing it to move, and hammer into the adjacent material, such as rock. Returning the piston. Once the space above the piston is full of compressed air, another valve opens, redirecting the air beneath the piston, and driving it back upwards. Air cycle. While the trigger is pulled, the jackhammer continues cycling compressed air, causing the chisel to repeatedly impact and break apart material. Chisel. To withstand the blow of the piston, and the impact of concrete or rock, jackhammer chisels are often made from hardened steel. Please like, share and subscribe. visualgk.com